We're going to go ahead and do this, this assignment. Tangent and cotangent assignment here. I'm going to go ahead and list the amplitude in this case. The amplitude is the absolute value of 2, which is equal to 2. This is no reflection. Vertical shift, yes. The period, once again, period for tangent is pi over b. In this case, it's pi over 1/2, which is 2 pi. And there's no phase shift. For number 2, I went ahead and rewrote it. Y equals 4/3 cotangent parentheses 4x minus 2 pi plus 1. The amplitude will be 4/3, the absolute value of 4/3. Is there a reflection? I would say no. There isn't a negative in front of 4/3. Vertical shift, it does move 1 unit up. The period is pi divided by 4. And I'm going to go ahead and highlight what I'm talking about. So, for example, 4 is right here. 4/3 is here. It's a number right in front of cotangent. There's no reflection because there isn't a negative. Vertical shift to 1 unit. It's right here. Vertical shift to 1 unit. And then phase shift to the right. And it's 2 pi. The amplitude is 5, and you see that right here. The reflection is seen in the negative, so it does reflect. Vertical shift, there's none. It would have been right here plus a value. The period is pi over b. The b value is right there. It's 3. So we have pi over 3. And then since it's plus pi, it's going to shift to the left. Let's go ahead and discuss the major points before I graph. Y equals tangent of x plus 2. I know that the period, and I'm going to highlight, I know the period is pi over b, and you find b right here next to the x. And so the period is pi. The the midline is 2, and where do you find the midline? Right here, it's right there. The left asymptote and the right asymptote, the left and the right asymptote, you always go to the parent function. And what you do is you get this x value and you set it equal to the parent function asymptote, which is negative pi over 2. And the right one, you set x equal to pi over 2. And then solve for x. In this case, it's already solved for x, so we know that the asymptote is at negative pi over 2, which is right there, and then pi over 2 is right here. The d value, which is the new midline, is going to go up 2 units. We know that tangent at 0 is 0, but then you have to go up 2 spaces. And then you're going to follow the pattern. It's going to have, you're going to go down 1 over 1. That's going to be your minimum. You're going to go 1 to the right and up 1. That's going to be your max. And then you go ahead and draw the curve. This right here, if this is pi over 2, then this is pi over 4. And if this is negative pi over 2, then this is negative pi over 4. And of course, this is 0. And there is 1 cycle of tangent of x. I'm going to graph number 5, y equals 2 cotangent of x minus 3. We know that the amplitude is 2. Remember, I get that from right here. This is a 2. The b is the 1, which is right next to the x. And then the minus 3 is the new midline. And then to find the left and right asymptote, the left asymptote is when it's undefined, and the right one is also going to be undefined, so we know that x is equal to 0 and x equal to pi. And we notice that we have here just x, so we didn't have to solve for x to find the left and the right asymptote. So I'm going to go ahead and graph where it's undefined. It's undefined at 0, and it's also undefined at pi. I know that the new midline, which we say it's the new x-axis, is going to go down 3 units, 1, 2, 3. So I'm going to go ahead and draw cotangent at pi over 2 will be right here. And I notice that the amplitude is 2. So remember, cotangent is going to be it's going to look as a reflection of tangent, or it's going to be a reflection of tangent. So I'm going to go over 1, go 2 spaces, go over 1 to the right, and go down 2 spaces. All the vertical, the amplitude effects is it makes it more steeper, the graph for cotangent, and of course it's going in the opposite direction of tangent. We're going to be graphing y equals -3 tangent parentheses of 1/2 x plus 1, or tangent of 1/2 x plus 1. We notice that the amplitude is the absolute value of -3, and once again I get it from here. The period is pi over b, and the value of b is 1/2. The new midline, which I didn't write, the new midline will be d equals 1. D equals 1. Now the only thing that we had to show some work was actually the left and the right asymptote. Since we affected the period in the equation, we got to figure out what is the left asymptote and what is the right asymptote. And how do you find it? Like I told you in class, you have 1/2 x equals the parent asymptote. Let me make a note. This is the parent. This is the parent asymptote, which is -pi over 2. And this is also the parent asymptote. So you have 1/2 x equals -pi over 2. You cross multiply, so you have x equals -2 pi over 2, which is -pi. So your asymptote is at -pi. And then the right asymptote is 1/2 x equals pi over 2. And once again, we got this from the parent. So we got to solve for x. 2 times pi gives you 2 pi over 2, which gives you pi. So this is the right asymptote. And remember, at 0, it's going to be, well, I take that back. We have to write the new midline. Since the midline is 1, we know that the x-axis has shifted up 1. So we would have said that tangent at 0 is 0, but we have to go up 1. And since there will be a max and the min in between from 0 to pi, in this case it's pi over 2, and over here it's -pi over 2, we know that it's going to be max and min. The way tangent is, you have a max and then a min, but since it's a negative, there's a reflection. So now we're going to have a min first. So we're going to go down 3 units, 1, 2, 3. And then at pi over 2, we're going to go up 3, 1, 2, 3. And yes, now it looks like cotangent. We're going to be graphing cotangent. We know that A is going to be 1/2. I know that D is equal to 1. So let me go ahead and graph 1 here. So there's our new midline. I know that the period is 3 pi, so now we got to figure out where's the asymptote. So we know that the left asymptote is going to be 1/3 equals, once again, I wanted you to think of this as your parent asymptote. And then you solve for x, in this case it's 0. So this is your left asymptote. And then our right asymptote is at 3 pi. How did I get 3 pi? I'm going to show you right now. We have the reciprocal of 1/3 is 3/1. So you have 3 times pi, which is 3 pi. And in between 0 and 3 pi, we're going to figure that out. We know that this is pi over 2. This is 2 pi over 2. This is 3 pi over 2. This is 4 pi over 2, which is 2. And this is 5 pi over 2. We're going by halves. So to find the middle, it's going to be 3 pi over 2. It normally would be at 0, but there was a shift to the up 1 unit. We know that in between 0 and 3 pi over 2 is pi, and it's going to go down, or in this case it's cotangent, it's going to go up 1/2. And then in between 3 pi over 2 and 3 pi is 5 pi. So we know it's going to be right. I made a mistake. In between 0 and 3 pi over 2, if I were to do the arithmetic here, it'd be 1.5 over 2, which is 0.75, which is actually 3 pi over 4. So it should be right here. And in between 3 pi over 2 and 3 pi, which is 1.5 plus 3, if I do that, 1.5 plus 3, I get 4.5. So I get 4.5 divided by 2, because I want the middle, divided by 2, you get 2.25, which is actually 9 pi over 4, which is 9 divided by 4. I think that's 2.25, yeah. 9 pi to it, so it's going to be right here. So in other words, I'm just getting the middle and then breaking it down to the middle. And so here is cotangent. And what I'll do in the video is I'll zoom in so you can see how I broke it up into quarters. So remember that from 0 to 3 pi is a period. Half of 3 is 1/2. 1.5, or 3 over 2 pi. And 1/2 of 3 over 2 is actually 3/4. So 3/2 is 1.5 divided by 2 is 0.75, which is 3 pi over 4. That's how I got that point. And in between 3 pi over 2 and 3, which is actually 3 plus 1.5, you get 4.5. Divided by 2, you get 2.25. And that's how you get 9 pi over 4. So I broke it up into quarters. The period is still 3 pi. We're going to graph number 10. We have y equals negative 1/3 cotangent of x minus 1. I do know that the amplitude is 1/3. I know that the value of b is 1. And I know that the value of d is negative 1. So what I'm going to do is I'm going to go ahead and graph the new I'm going to go ahead and graph the new midline. Remember that the left and the right asymptote, you have x equals the parent asymptote. In this case, we know the parent for cotangent has an asymptote at 0. And we know the right asymptote is going to be at pi. And we know the cotangent at pi over 2, in this case, is going to be at -1. Now at pi over 4, and then we also have 3 pi over 4, we should have a max and a min, but since we have a negative, it's gonna have a reciprocal. So cotangent is usually like this. So it's gonna reflect. So now we're gonna have a min. So 1/3 is gonna be right here. And 1/3 is gonna be right here. So it's gonna look like, it's actually gonna look like tangent. What I did is identify the asymptotes. I knew there was an asymptote here. I knew there was an asymptote here. I had to do some thinking. I knew that here at 1, these are the points, the turning points, so I knew that the D had to be 1. I noticed that my left parent and my right parent, I should have had asymptotes at -pi/2, but it shifted to the right. It shifted to the right. So the question was, how much did I shift? Well, here it's 2 pi/4, because I broke it up into quarters. 2 pi/4, it shifted to 3 pi/4. So when I did the difference, it was a shift of pi/4. And since I'm moving to the right, it's going to be minus. So that is my formula, y equals tangent, parentheses, x minus pi/4, close parentheses, plus 1. It made me think. It did make me think. So we have d equals 1. The phase shift to the right was pi/4. That's what you have a minus. And it was a tangent graph. Okay, I started by identifying the asymptotes. And I saw the first asymptote at x equals 0. I saw the second asymptote at pi, and I noticed that it repeats. So therefore, they give me a clue as to what type of graph I was dealing with. I'm dealing with cotangent, because I know it goes from 0 to pi. That's the period. And I forgot to write the period here. I also noticed that I know that at pi/2, cotangent is 0. And I noticed it went up 1, 2, 3. And I also noticed it went down 3 units. And this is 3 pi/4, and this is pi/4. And I'm going to show you right now in decimals, but you notice when it's 3 pi/4, it goes down 5 units. 1, 2, 3, 4, 5. Which it goes down, the amplitude was 3, so it goes down 3, and it also goes up 3 from the midline. So this is y equals 3 cotangent of x minus 2. For number 14, I use decimals. I'm going to be honest here. I know that the period is 4 pi. So from here to here is 4 pi. I know it was tangent. And I know it's a reciprocal. So what I came up with originally was tangent of 1/4 parentheses x plus 8 pi. And I'm going to tell you why. We know that originally the left asymptote is at -pi/2. And the right for the parent is pi/2. And so I needed to shift. I needed to shift this graph. So I have y equals negative tangent 1/4, that's your b, x plus 8 pi. Now, if I were to do the distributive property, you would see the shift negative tangent 1/4 x plus 2 pi. So you notice that this would have had to shift 2 pi units to the left. And that's what this graph did. It shifted 2 pi units to the left. Okay. I first identified the asymptotes. We had x equals 0 and then x equals pi over 2. I know that the period is pi over 2, so therefore I knew that the b value had to be 2 because I know the period for cotangent is pi. So in this case, it's going to be pi over 2. It's going to be split in half. It is cotangent because it's going in the opposite direction of tangent. So what I got was y equals cotangent of 2x minus 2 because that's the new midline.